Find this integral here, and part B, we've got this sketch. It says the diagram shows a sketch of the curve y equals 9 minus x squared, which intersects the positive x-axis at the point P, A0. Find the value of A. The tangent to the curve at P intersects the y-axis at the point Q, so that's up there, 0B. Show that B is 18, and find the area of the shaded region. So let's have a look at this then. We'll work out this one first. So this is 5x to the minus 4, isn't it? So it would integrate to 5 lots of x to the raised to the power by 1, divide by that number, minus 7 lots of x raised to the power by 1 up to 5/3, divide by that number, plus the constant of integration. Now let's tidy it up. Minus 5 over 3, x to the minus 3 then, minus, the 3 swings up to be with the 7 to make 21, over 5, tap it in the calculator if you need to, x to the 5/3 plus k. So we've got that. Part B now, find A. So for part 1, let's put it over here. So here, this value here is when the y value is 0, so 9 minus x squared equals 0. X squared equals 9, square root both sides. X is equal to plus or minus 3. So the positive value will be the 3 value, won't it? X equals 3. Show that B is 18. So the gradient we need, don't we, to get the gradient of the line. So the gradient of the line, so part 2, dy dx is the gradient of the line, is equal to, differentiate this then, that goes to 0, this goes to minus 2x. And we're putting in at the value 3, aren't we, the gradient at 3, equals minus 6 at x equals 3. So that's the gradient. So if you think about the gradient of the line, here's the angle. That's the tangent. It's the opposite, which is B, over the adjacent, which is A. But it's minus B because it's going down, isn't it? So tan alpha is equal to minus the B because it's going downwards over the how much it goes along A. The tangent of the angle alpha is the gradient, which is minus 6. A is 3. So that tells us that B is equal to 6A, which equals 18. So B is 18. So yeah, that's fine. B is equal to 18. So that's that one done. Part 3, find the area of the shaded region. Well, this line here is y equals, this curve here, straight line, is equal to mx plus c, so it's 18 minus mx, so there's the line then. And it's the difference in the heights, isn't it, will be these segments here between 0 and 3. So the area, part 3, so the area of the shaded region then is equal to the integral between 0 and 3, and the difference between the y values, 18 minus 6x minus the 9 minus x squared. So there's a difference between the curves, 0 to 3. 18 minus 9 is 9. Minus minus is plus x squared, and then we've also got the minus 6x. So integrate this then and see what we get. It's 9x x cubed, raise the power, divide by that number, minus 6 raise the power to 2, divide by that number. And that needs to be evaluated between 0 and 3. 6 over 2 is also the value 3 lots of x squared. So it's equal to then top value, put 3 in, 27 there, plus 27 over 3 is 9. Put 3 in here, we get 27 over 2. That's the top value then. Take away the bottom value, which is 0, and that's all 0. So that's equal to then 27 over 2. The difference of this 27 and 27 over 2 is just 27 over 2, which is 27 over 2 plus double this, we get 9 twos are 18 over 2. So that would be 3745 over 2, which is equal to 22.5 units squared, because it's a measure of area. Looking through this, I can just spot one tiny little error, because I left the 2 in. The 6 over 2 is 3. Minus 3x squared, this would also be minus 27, so let's just make that correction. Now I've looked at it. So this is minus 27, and this would just be simply 9 then, wouldn't it? Which is even easier than before. So just make that change then. So that's equal to 9 units squared.